So I will be speaking on behalf of the CINES team and some of the guys that work on this solution. And so the idea is to present GAIA, which is a process that we use at CINES to deploy and answer the needs of our users. So who are we? So CINES is one of the 3 national centers in France. So we currently operate the Adastra machine. So this is a Cray EX machine and currently made of 3 partitions, so a CPU partition, MI250X, which is very similar to the one that you will have on Frontier, for instance, and a smaller partition, which is made of MI300A, which you can find on the El Capitan machine. So it's a mix of our partition, and we all need to support them. We need to support all these partitions and provide the software to use it. So let's start with a little story. So back in the day, which was actually 3 years ago, we operated another machine which was called Oxygen. And this machine, while it was working very fine and our users were very satisfied, it was very traditional, so CPU only. And most of the software was built manually. So the team was, let's say, storing a list of recipes and manually building depending on the need. And while it works relatively well, as I said, it was a very traditional CPU machine, and we were benefiting from the 15 and plus years of expertise and how to build some software. And so, unfortunately, if we go back to the current world, so we get more powerful machines, which are unfortunately getting also more complex, and software is also getting more complex, and so manual completion is less viable. So we needed to change. And in addition to the ideological changes, for instance, the fact that there is Python everywhere, the thing that the pace at which the software is being developed is much higher than earlier. And to that, we add the dependency L and the idea that on HPC, generally, we have a lot of heterogeneity. All of this does not fare very well. So notably, the dependency L and the heterogeneity, it's a real pain. So we needed to fix that. So the current problem is that we have many users with different level of expertise, and actually our kind of users are very similar to the one of the previous talk. So some of them do not even know what is a compiler. So we need really to support them and provide software for them. So some other users do know how to compile, but there is no guarantee that the software that they are going to build is going to be correctly using the hardware. So often we see poor hardware utilization due to the badly configured solution. Or even worse, sometimes we can have buggy results and buggy science, for instance. So what we need is so this point. So we want something that is composable. So for instance, if I have package A and package B and C that depend on A, we want that if we modify package A, that the other packages are also going to benefit from these changes. We want a lot of flexibility due to the hardware heterogeneity, and we want to be able to tune things. And most importantly, it's the bottom one, we want low latency. So the main issue is that between the time that your users ask for a product, we want to quickly answer that need and provide a solution. And so, yes, we're very much, what is very important is this latency. Throughput is much more easier to attain, and latency is generally the issue. Yeah. So package manager, I'm going to go very quickly on that. But the TLDR is that we ended up using Spack because it satisfied our need much better. Especially on the community side and on the quality of the recipes and the availability of the recipes too. And so we get to GAIA. What is GAIA? So it stands in English for Automated Application Installation and Manager. But basically, it's a process. So it always starts with a user ticket, which will then be translated into an internal GitLab issue. And then internally, we start iterating and producing something that will work depending on the need of the user. At some point, it gets merged into a develop, and then some files will get written onto the disk, and the user can start testing if the solution that we provided is working for him. Yeah, and when the develop is ready, at some point it gets merged into the master, and then the pipeline runs again, so some files are produced on the file system and then are available to all the users, but this time as under a release, which is going to be stable for many years. So yeah, it's mostly a process. And while there is no strong guarantee in develop, so we can change the package, upgrade the package, change the variants, and things like that. Once it's in the release mode, then we can support it for actually many years. So since the start of the machine, we have some users that are using the same packages for more than 2 years, and it's working actually very fine. So a few specificities that we have on our Spack configuration. So we use unify all false. This gives us more flexibility, but this also creates a lot of issues related to the management of our dependency. So we don't, because for instance, the library is able to. So we need to be more careful about what is getting linked to an application, because potentially you can end up with 2 different OpenMP backend coming from 2 different compilers into one final binary, and this generally don't work very well. So ideally, each application will be built in isolation, basically choosing the latest version of all the packages that it needs. But the library that we offer should then all be built as part of one big AMP, one big environment, and using a unified GAIA to prevent this issue of having multiple, let's say, backend, OpenMP backend in different libraries that we will end up linking into one final binary and creating issue. So this is a flexibility versus correctness dilemma in this case. Because we have a Cray machine, we have a lot of issues with Cray also. And so we have many recipes workarounds, some of which we have upstreamed already, and we will continue to do so. And one specificity that I have, that we are using and that we do not see often on other sites is the fact that because we use Cray and we use the wrappers, and because we have different partitions that we want to target, we need to use the modules that Cray provide. And for that, what we do is that we will have, for instance, a GCC compiler, which we will suffix the version using, let's say, MI250X. And this will map then to this list of modules. So this will be in the compilers.yaml. And we can see that we will load some modules that are specific to the partition. And in this case, this will be a compiler that is related to the Genoa partition, so the CPU partition. And there is no GPU stuff. So the most common issue that we have using Cray and Spack are mostly the recipes. So many recipes do not expect Spack, do not expect the Cray stuff, and most especially the wrappers in every flavor actually. So MPICC, PCC, Cray, all of these wrappers are always a pain. It's one of the most significant issues that we have. Fixing the wrappers. We have a POC that allows us to work completely around Cray except for the MPitch and the GTL that comes with it and is necessary to target the GPUs. But it takes time to make that switch and use that completely. Yeah. Then the modules, so we produce binaries, we have products, and this one, we don't want to have one big wall of modules. So we have some site that we know about that, and when you do module avail, we just end up with 800 modules, and you don't know which one is compatible with which, and how to make them interact. And so we wanted to avoid that. So what we have is that we have multiple, what we call stack, which is basically a Spack environment behind that. And using lmod and some fancy modular rewriting, we separate very cleanly which module we have to use to load which stack, and then we only expose the products inside that stack. So it looks like that. So there we can see we have a production and a deprecated section. And so for each flavor of compiler and partition, we will have different variants. And this what we call stack, are completely, you cannot load 2 at the same time, so it's exclusive. We also notice that we have some develop, so this will be, you will have to load that to expose the latest stacks that are currently in development, and at some point it gets deprecated and then into archive. This does not, there is no support then when it's in archive, but as I have told you earlier, we have users that have been using it for more than 2 years without issues. So you cannot mix stacks, so as I said, but there is what we call a base stack, which is basically a collection of all the small utilities that we need and do not really depend on a partition. So for instance, you will find CMake, Spack itself, and stuff like zlib and stuff like that. And generally, the idea with the tools and the libraries that we have inside that is that we can link them with any products that we will have in the stacks without fearing a linker issue or things like that. And generally, we try to tie a CPE release with one of our relays. So all of that was to lower the latency, but there is still a high latency, notably when we have to iterate in this part. So when we want to find the correct set of variants, for instance, that will satisfy the users. And so what we do instead is that we provide what we call a Spack user, which is just takes the form of a module, which when you load it will copy the Spack configuration that we use into the user shared directory, for instance, and then he can himself work using Spack to iterate, but directly inside his office directories. What happens often is that we will inject ourselves into the project of the users, and then we will iterate much more closely with the users to produce binaries that suits him. So this is one of the most useful tools that allows us to lower the latency, mostly for complex projects that requires a lot of user support interaction. A small note on regression testing. So on the premise that HPC is very heterogeneous, so the hardware, the environment, and the software, generally testing the performance of a system requires tuning for that system. There is no magic there. You can't just take the HPL on Frontier and run it on El Capitan, it just won't work. And so, yeah, it's hard to reuse others' work when it comes to benchmarking, and I mean really benchmarking, not just launching something and checking, assuming that you want to use the hardware to the max. And so we have two ways to do that. So we use Reframe for most of the naive tests, which the ones that are generally not very well tuned for the system. This is just for testing that the binary just does not crash, for instance. And it works very, very well. There is a nice synergy between Spack and Reframe, notably for testing the Spack products. And then we also have an homegrown solution, which is very versatile, very large, but it's basically just a list of Bash scripts and Python. Obviously, all of that generates a lot of data, and then we can do reporting and time series and things like that to monitor the performance. But the important fact is that we have basically two regimes, one for a naive test and one for very well-tuned tests. Looking forward, so we still have some issues. So Python is one of the biggest issues. So there is a lot of inodes, and so we need to factorize that. But the issue is that even if we create some pre-built or pre-made Python environments, it also works when the world changes very fast, for instance, in AI. And especially for AMD hardware, where every day you will have new releases and you need to keep up with that. So we don't know really how to solve that, except maybe have a pipeline that each night will run and repull the packages. But even that does not work because the dependencies between packages, Python packages, are not always very well constrained, and sometimes you end up with recent packages that breaks the other one, and so it's a real pain. So we don't know how to solve this one. Maybe we just need to wait for something to stabilize. So we will continue fixing packages and making some pull requests, notably for the Cray and heap variants of the packages, because currently it's not as good as it should be, we believe. So recently, for instance, we upstreamed the GTL fixed for Cray and Fitch. So the goods. So now we are no more limited to the teams. So previously, when we were doing manual builds, we were limited by the size of the team at CINES. Now we can benefit from the Spack work and the community, basically, which is great. So we have composability and a bit lower latency than before. Now it's more about finding the right set of variants that we can enable on the product, more than just building and doing the dirty work of. So this has shifted a little bit. So that is also bad. So there is a lot of inode, and we don't know how to fix that. So there is some naive issues, a naive solution, sorry, about using SquashFS, for instance. But this has issues with the memory usage. So there is no real solution for us, at least for now. So even though the latency is lower, there is some issue, notably because the list of broken packages is way too high, at least for the machine that we target. And so we spend a lot of time actually fixing the packages, sometimes not very cleanly. So this is why we do not upstream everything. But this is maybe the most limiting factor for us, the latency. This is the broken packages that we need to fix. So this is more than a feeling than I don't have something very precise to show about that, but we feel that maybe if Spack would be a bit more stricter about the way compiler wrappers are enforced into the recipes, it would allow us to quickly or more easily inject flags and fix some very simple issues that sometimes require a lot of work when we want to fix them properly, cleanly inside the recipe. So in fact, there is so many packages that just bypass the Spack wrappers, and this is a pain. And also, we believe that there is too many ways to do something in Spack, and there is some better ways to do something, and due to the large variety or the way you can do things, often the way chosen is not the best. And so yeah, there's the ugly to finish. So we have HPC, very heterogeneous hardware, and so we also have very heterogeneous software, and this creates a lot of build issues. And unfortunately, most of the time is spent, for instance, in mailing list, trying to figure out which is the secret sauce for this package, so we can get performance, because on hardware, the default variants will just not work. So yeah, the secret sauce is maybe a bit harder to find for us, actually. And that's it. Thank you.
Thank you, Etienne. We have a couple minutes for questions.
So you had a slide that talked about the Cray compiler wrappers. Do you want your build to use the Cray compiler wrappers? Because we've actually stopped using those in Spack, and we try to use the more deterministic standalone compilers. But I guess my question is really more like, given that, do you want the Cray compiler wrappers to be in your module hierarchy? Is that what you're saying? Or?
Yeah, it is.
Yeah. Okay, so that's an interesting thing that we haven't.
We are in the process of removing that because it creates way too much issues. So yeah, actually it's not that hard to not use Cray except for the mpitch and the GTL. So if you only do CPU builds, then just linking mpitch is very simple. But then there was no support, at least until recently in Spack, to link correctly the GTL, which allows the GPU direct and GPU aware stuff. But now that it's been merged, I think 1 or 2 months ago, actually we can just ditch everything in Cray and build from scratch most of the thing. And this is probably what we are going to do, because the cost of the Cray wrappers, and as I said, not only the Cray wrappers, but all wrappers, is way too high. So, for instance, there is a lot of work in Spack to make MPICC, for instance, work. There is a whole section in the documentation on how to use it and how to package around it. It's just a pain. And so, yeah, all wrappers are a pain. And we want to work around that.
All right, thank you, Etienne. That's the end of this session. We have a break coming up now, and we will be starting with lightning talks after the break at 20 minutes till 4. Thank you all.